This week on Quality Digest Live, the power of teaching and managing by the numbers.
That's right. And can making mistakes, kind of like this, lead to organizational improvement?
I hope so.
We'll find out when we come back. Welcome back to Quality Digest Live for September 28th, 2012. QDL is your weekly look at who and what is making the news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
And I'm Quality Digest publisher Mike Richmond. Okay, we got a full show on tap for you today. So let's dive right in with a news item highlighting a recent survey from the Automotive Industry Action Group and J.D. Power and Associates. According to the survey, which was conducted with top managers among automotive manufacturers and suppliers in North America and Asia, new and better methods are needed for measuring and improving industry quality. That's because the industry has made a habit of tracking trailing indicators, such as perceived customer satisfaction and/or initial problems per 100 vehicles. A better option is to consider leading indicators of improvement, such as those found in design and planning processes. This piece returns us to a theme that we've touched on a few times in recent weeks here on the show: perception versus reality of quality within the automotive industry. We've talked about it how many times?
Oh,
3 or 4 times,
yeah,
at least in the last month.
Yep.
We've usually approached the issue, if you watch the show, we've usually approached the issue from the perspective of the customer. For example, many U.S. consumers believe that there's a large gap in quality between domestic autos and foreign nameplates. Buyers are even often willing to pay much more for a foreign car, even if that car has similar features and reliability to a domestic model. Again, we've seen it a lot. People are willing to pay more for a foreign, a Honda, let's say, versus a Ford that maybe has exactly the same features, has the same reliability. They'll pay $5 grand more. Why is that? Perception versus reality, sure. Okay, the perception versus reality issue affects the industry from the inside out as well. If the survey is to be believed, the industry is trapped by the perception that systems must be put into place to limit poor quality rather than enhance good quality. That's the current state map. On the bright side, the managers responding to this survey understand that the future state map has to have a very different look and feel. That means better predictive tools, closer benchmarking and collaboration with other manufacturing sectors such as pharmaceuticals and aerospace, and ultimately a better alignment of business objectives and quality philosophies. Now that one's probably the toughest one, that alignment, because it's hard to really walk your talk, right? I mean, you say you believe in a certain thing from a quality perspective, but the business objectives of that, in terms of maybe cutting costs or cutting corners, whatever the case may be, sometimes overrides that. So you have to kind of decide what you're really in for, what you really want to do.
Sure.
Do you want to really walk the talk of that? Do you want to make quality the culture of your business or not? I mean, do you want to go with slogans and pitches, or do you want proven and continuous improvement? That's forward-looking, systematized, and repeatable. Which one do you want? That's really the question that's at the heart of this thing right here.
Right.
The perception versus reality of that. And the survey unveils or kind of reveals, I guess, some of these issues, some of these perceptions, where currently it's not that. There's trailing indicators that these managers are looking at and dealing with, and they realize that in order to improve, that they need to have different metrics. They need to adapt different things, but that's in the future. And how are they going to get from A to B? Well, that really isn't addressed, and I'm not sure that anybody really knows that yet. But the AIAG and J.D. Power and Associates is really on it, and they're going to be looking at this as we go forward. So for more information on the survey from the AIAG and J.D. Power and Associates, go ahead and click the story link just below the player page right there, and you'll navigate out to a story, and you'll be able to get the survey and check that out. And I do recommend that you look at it, because I think these are important issues, and it's one that, hey, we've touched on it time and again, within automotive sector, perception versus reality, it's important that we all understand what that really means.
Right. Interesting story from J.D. Power. J.D. Power always has interesting stuff, particularly on the automotive industry.
Yep, they do.
I want to touch on several articles that we ran this week. The first one was from David Schwinn. Now, Schwinn is a full-time professor of management at Lansing Community College and a part-time consultant in the college's Small Business and Technology Development Center. He's also an associate of software company PQ Systems. So in his story, Schwinn is recounting how all through his college days, he was taught enumerative statistics. These are essentially descriptive and inferential statistics that help you to make decisions about what you have in your hand. You know, you've collected some data, now you're going to take a look at the data and infer something about something that has actually already occurred. And this is versus analytical studies or analytic studies that help you influence the future. And this is kind of what analytic studies are, what we're basically taught by Deming, right? So what Schwinn says is that you never even used control charts until he started working in industry. And this is strangely, analytic statistics, as powerful as they are, weren't taught in college courses when Schwinn was taking them. It wasn't taught in the courses he took or others took. We've heard about this before. Nor was the idea really of process variation. So the thing that's interesting about this is here's something that's critically important to industry. I mean, we talk about process variation all the time. It's what control charts are all about. And yet when you take your standards statistics course, Davis Balistracci has talked about this as well, you're taught these like high-end, enumerative statistics, and it goes really deep, and it's like, well, that's not really what you're using unless you're an academic or in certain areas of industry.
Sure, it's pure theory. And it's interesting because statistics, when I read this article, I thought about this. Statistics is such an applicative, is that a word?
Sure.
It can be so easily applied to industry, and it's so important to be applied to industry, yet there's no real hands-on, roll-up-the-sleeves training in this way, as we're talking about, that really allows people to go out and begin to work in that field with the knowledge that they need.
And what's interesting is that keep in mind that what he was teaching was for managers.
Right.
Managers don't need to have the super high-end statistics. Even if you can make the argument that, well, in manufacturing sometimes you do need these high-end statistics. Davis says, well, yeah, maybe 5% of the people do, the rest of them don't. But managers definitely don't, I would say. What they're really looking for is things like analytic statistics, like control charts and stuff.
Sure.
The stuff that Deming taught. So imagine Schwinn's chagrin when years later, actually just recently, having been asked to take over a managerial statistics course at the college. This was what I was just referring to. Mm-hmm. He was asked to take over a management statistics course. He discovers that in the existing syllabus and the textbooks, the emphasis is all on enumerative studies. Now Schwinn's coming out of industry now, and he's going, wait a minute, you want me to teach statistics for managers, and you're still got the same textbooks and course syllabus that I had, 30 whatever years, when I was in college, right? So Schwinn is changing up his course by bringing in new materials that emphasize analytic studies and giving students, new students, the tools they need to function in a real world where being able to influence the future is a lot more important than simply telling what has already happened. So this becomes kind of the enumerative versus analytic statistics, and which one is more important. And to quote my friend Davis Balistracci, well, it depends.
Yeah.
Now Balistracci would say, well, you never need it, but he's pretty much a hardliner on that. Yeah. But the point is I think in what I get out of talking to Balistracci and Thomas Peisdek and Wheeler and David Schwinn is that really it depends what you're doing. Mm-hmm. So you can't, and I don't think Schwinn would try to rule out enumerative statistics. There's times when you need it depending what you're doing. But typically in industry what we're talking about is we want to know how our process is doing. We want to know about variation. We're interested in analytic statistics. And the reason I actually brought up this article is because there's always within us, let's say statisticians or people who work with statistics, and we're kind of talking at this point, or I'm going to talk about the Lean and Six Sigma crowd, is there's always what kind of data do you use, how do you use it, and you get into these kind of sometimes really heated discussions about who should be doing what and when. You've seen the big discussions between Don Wheeler and Forrest Breyfogle and Stephen Ouellette, and do you normalize data, do you not normalize data, and you get in these big old discussions. We had another article that came up that I wanted to point out because mostly I want to point it out because of the comment that was at the end of this. This article was written by Kyle Toppazini, and it sparked a kind of a heated debate. And the article was "Lean without Six Sigma may be a failing proposition," in which Toppazini basically says that standalone Lean has limitations that, of course, ruffled quite a few feathers.
And he also said the standalone Six Sigma may have limitations too, if I could infer that.
Yes, I think he did say that.
Yes.
He says, well, you need, or you have to have, and he did use fairly strong language. He said basically you have to have both, of which several lean proponents said, well, wait a minute, no, you don't.
Right.
And Kyle said, well, yes, you do. And my feeling is, well, it all depends on your perspective.
Yes.
And what I mean by that is, how do you define lean? How do you define Six Sigma? Some people define Six Sigma very narrowly. They define it kind of the 1980s version of Six Sigma that was very narrowly defined.
Which is the way I've always learned it. That was the lowercase Six Sigma. That was the Six Sigma with a lowercase. The Six Sigma with the uppercase is the more methodology-based.
Well, no,
Six Sigma.
even the uppercase Six Sigma, as Michael Harry put out, was also was fairly constrained. It was a very kind of set program, but it really expanded from it. Even Michael Harry, in interviews I had with him later, he said, Six Sigma is really, it's got a life of its own. It's kind of expanded. So for some people, Six Sigma is holistic, involves the entire company, including management, and involves ideas like lean, like zero defects, like ISO 9000, because it becomes more of a holistic thing. For some people, Six Sigma is very narrow. So this brought up this whole argument, and this, Kyle and a couple of our readers were going kind of back and forth on this. And one of our favorite commenters, who comments on a lot of stories, Rip Stouffer, commented and left a rather lengthy comment. And I encourage all of you to go to the article. The link is at the bottom down here. You don't even need to read the article. I would just skip right down to the bottom to the comments section. I think Rip's comment is right near the top. Read what Rip has to say regarding this whole ball of wax, statistics, lean, Six Sigma, other quality programs. It's really worthwhile. But I want to share with you just the very last paragraph of this, if we can just bring it up. Rip says, "My own view is that we'll do much better as quality professionals when we stop the infighting about what we call things and start rendering unto lean those things that are lean, and unto Six Sigma those things that are Six Sigmas. Learn systems theory, statistical theory, at least as it applies to analytic studies, psychology and sociology as they apply to organizational change, and what Rogers called diffusion of innovation, and pick up a useful iterative learning model to guide the approach and drive organizational learning and change. Learn which things are important to measure to actually drive improvement, then work to get things on target and constantly and forever reduce variation. Channel the value streams, optimize flow through these streams, and optimize the system." That, in a nutshell, I think, is what everybody should take away when you see these arguments. We've had big arguments between Forrest Brayfogle and Don Wheeler, and we've had arguments between let's say Mark Graban and Kyle Topazzini. Let's say they're all valid points. They all make good points. They all have kind of their own turf and their own direction that they're moving with their customers. What Rip is saying, look at all of these things, pay attention to them, and take from them what is valuable for your company, regardless of the marketing hype, regardless of what naysayers or proponents may say about one thing or the other. It's what counts for you. It's what's good for your company.
And semantics play a big part in this too.
And semantics play a really big part.
I think people jump on a term and they identify in terms of all sorts of connotations, and they hear Six Sigma and they immediately jump to conclusions about what that may or may not be.
Right.
And maybe that's okay. We all have to have a point of departure where we have to start from. But maybe what you're saying is really true. Maybe what Rip is saying is really true too. That taking a broader approach and looking at all the inputs that go into this is really the way to look at it, rather than to narrowly focus on any one particular tool or one particular application. It's really what you're doing.
Right.
What you're doing with it is what you're going to get out of it, and it's what your culture's about. Because that really is what it comes down to: is what you need and what you can get out of it. So. I think both those things you talked about, going from David's article on to Kyle's article, I think it is a natural progression. I think it's important for people to be aware of these currents of thinking that's out there and check that out. So great. Thanks, Dirk.
You had an interesting story.
Yeah, I did. I did actually have an interesting story this week from a pair of writers, new people to Quality Digest. The article was entitled 5 ways your business can improve by admitting mistakes. And that was by Michael Houlihan and Bonnie Harvey. Michael and Bonnie are the founders of Barefoot Wines, which is a very successful. We happen to have a Barefoot Wines bottle.
Barefoot Wines.
Right there. Dirk is oh, there it is. Well, thank you, Dirk. Bonnie and Michael are the founders of Barefoot Wines. They have a book coming out that talks about Barefoot Wines and their experience as a small and growing and now not so small business, and the things that they went through to find their success. And one thing that they talk about, and one thing that we pulled out in this article, is, again, ways that mistakes can help your business to improve, right? That's something that's very important. All of us have made mistakes. Dirk and I have made mistakes. Well, Dirk has. Dirk has made a lot of mistakes in his career, and he has learned many things from those mistakes. And to illustrate this article, Dirk, you may remember, we took some time earlier this week, and we had a small photo shoot which takes the 5 things, because there are 5 ways or 5 points that Michael and Bonnie talk about in their article that illustrate the different mistakes you can make and how you can heal and how you can repair those mistakes going forward. So let's show these photos. We're going to do one at a time, and each one of them kind of shows a different point that Bonnie and Michael talk about. So let's roll that first one there. The first one there is actually cop to it. Admit you were wrong. Now, as you can see here,
I do this a lot.
Dirk is good at this one. The sign says, "Yeah, it was me."
That's my wife.
Yes, and I think
yes, I did again.
I think actually, if memory serves, that this sign was given to you by Lynn as a wedding present.
Yeah, sure. Just
I think that she said that you should carry this with you at all times.
At all times.
In your marriage as well as in your career. Well, cop to it. I mean, that's what it comes down to, right? I mean, if you make a mistake, all right, and you know it, and your customer knows it, hey, right? I mean, there's no sense burying it under the rug. You made a mistake. You made an error. Say, hey, it was us. We did it. It was wrong. We wish it hadn't happened. It happened, and we're going to move on. First things first, so admit that it happened, okay? Second point. This is another good one right here. Recognize how it happened. Now, this, as you can see, is an image of me giving Dirk a muffin or a cupcake with a candle in it.
Yeah.
Why am I doing that, Dirk? Why am I doing that?
You should do it more often. Hard to get any food around here.
Well, I'll tell you why I did this. Because when a mistake happens, and you've owned up to it, you cop to it, right? And everybody knows that it happened. You want to recognize that it happened. You want to say, okay, you, Dirk, made this error. You made the mistake. As you can see, there's a bunch of cups down there that you messed up.
Yeah.
All right.
Yeah.
So it happened. Own up to it again. You admit to your customer. Now say, okay, this happened. What are we going to learn from it, right? How are we going to make that good? And congratulate you for doing that, because really, if the error was found and we didn't know that this thing could be messed up in this way, how great is that for the business? Rather than coming down on the person who made the mistake, say that's great. That's great for doing that. Not if it's a willful error, of course, but if it was a mistake that happened over the course of doing your work, say, that's good. We found that out. Now that we know that can happen, now that we know that mistake is possible, we can design something that can fix it, right? The old success lies on the other side of failure thing. Great point. Okay, third one now. Aim, don't blame. Aim, don't blame is the next one. Okay, and as you can see right here, Dirk is trying to reconfigure those cups that you knocked down. And I am writing down exactly what happened. See, what you want to happen here is you want to make sure the problem doesn't reoccur. You want to make sure that you understand again what happened, and you want to document and talk about what that problem was and how you're going to solve it, right? Okay. Next one ties in with that very directly. And the fourth one here is write it down. Document, document, document. Now, as you can see there, I'm giving Dirk a work instructions manual. Never make the same stupid mistake. Not that your mistake was really that stupid, but okay, it just helps to reinforce it. So that way we have it documented again, and we know what the mistake was, and we can make sure that it doesn't happen again. Because if you don't write it down, if you don't document it that way, you may think, hey, we're always going to remember what happened, we're going to always remember why this thing occurred, but you may not. And if you don't, you want to make sure you have it documented. Now, I want to point out one other thing, and if we can go back to that photo for a minute. You may see under Dirk's left arm, the cupcake that I gave him for making the mistake is no longer in existence at this point.
Hey, I'll make mistakes all day if you keep feeding me cupcakes.
Did you ever see the movie Gone in 60 Seconds?
Yes, that used to be my nickname.
Great
that
movie.
Used to be my nickname.
Well, I think in this particular photo shoot, I saw the prequel called Gone in 30 Seconds, because Dirk, and you didn't eat the candle, I don't think.
No, I left it there.
But you left it there. But anyway, so that's the fourth one. The fifth one is really the important one here, is resolve that it won't reoccur. again. And as you can see, Dirk and I are going into our customer here in our office, and we're bringing in the cups that are now stacked up properly. We have our brainstorming session and our work instructions so we can prove to the customer that this will never happen again. Well, that was our photo shoot yesterday. But the moral of the story, really, the moral of the story in this silly little thing, and with our wine here, the moral of the story with all of this is that mistakes happen, right? I mean, nobody wants them to happen, but they do happen.
Like, I won't spill any wine on you or anything.
Well, let's hope not. But
Okay.
that would be a mistake. I don't think these are the same cups that we had yesterday, but mistakes happen, as they say. They do, but it's how you handle them that really is what makes or breaks, because
and your customers appreciate it. I mean, they want to know that you can own up to what you've done.
Well, sure. It's an opportunity. It's an opportunity to get closer to your customers. It's an opportunity to learn a lot about your process. You really can't learn a lot about your process if things are just going smoothly. If they're going swimmingly and everything's working out just great, you'd never necessarily know if your processes really have some holes in it. So these 5 steps from Bonnie and Michael. Again, the article was 5 ways your business can improve by admitting mistakes, and that's Bonnie Harvey and Michael Houlihan. Read it again. It's right below the player page, right there. And
here's the mistakes.
And check that out. Here's the mistakes.
I'm sorry. Here's the learning from.
Here's the learning from mistakes. Thank you all. Thank you, Barefoot Wines for providing that article to us, and the wine.
And the wine. Actually, they didn't provide the wine.
And they didn't. No.
Feel free. Well,
anyway, thank you again for that. And again, check out the article. It's below the player page right there. Okay, we're going to move on now. And we have a really good tech corner for you today. We love when we can do tech corners this way, where we can have a guest come into the studio and show off a new product. We have Chuck Marks of OGP with us today, and Chuck's going to show off the new Vici Vision system, which is new to North America. And I'm going to throw it to Chuck and Dirk right now and show it off. Take it away, guys.
Okay, well, so again, Chuck Marks, thanks for coming back and visiting us up here in Chico.
No problem.
It's a slightly larger place than where you were last time.
There's a little more room, yeah.
When you came last time, what equipment did you show us?
We brought the Snap digital measurement system.
Oh, that's right, the Snap. And this time we have the Vici Vision.
Right, the Vici Vision. OGP is very proud to be able to bring that to North America. New product, new offering for us. What it is it's a shaft measurement system, and it utilizes a vertical travel profile light, and we're able to do a single pass and get a lot of dimensions very, very quickly.
Okay, run us through it.
All right, so I'm going to go ahead and start an inspection routine here. What you're going to see is there's going to be light coming from the left-hand side here. We have a collimated light source. It's going to come over to a camera array on this side, and we're going to see it scan up and do the measurement. So what we see right here is the system goes down at homes, does a quick check, make sure everything's working properly. We then move in, and it's going to move up, and it's going to do first a linear scan here that acquired all the dimensions in that particular orientation. You'll see it begin to do a rotation where we'll check some measurements on another orientation. And then we're going to do right here a dynamic measurement in which we're checking the roundness of the, in this case, the head of the screw. All right.
And the dynamic rotation works by simply rotating the stage as the camera stays in one place?
That's correct. The camera stays static. As we rotate around, we're counting the scale counts as we rotate. We're then taking the measurement data, plotting that against it, and then we can actually look here, and it'll give us a nice roundness plot. You can see there on the software, kind of lets us know that there's definitely a little lobing going on here. One of the great benefits, the Vici X5 here is really designed for the smaller medical parts. So dental implants, the bone screws like we have on here. The reason why is we have a very high definition camera array set up on this particular one. Travel on this one is 16 millimeters wide by 100 millimeters long.
Okay, and just to clarify how this works again, you've got a green, it looks like a green collimated light source.
That's correct.
Hitting the object from one side, and then like a line scan camera on the other side that's tracking with it.
That's correct. As that moves up, it creates the 2D profile of the part.
And then you simply rotate the part so that you can capture the profile from different angles as you go.
That's correct. That's correct. So some of the dimensions we can do, for instance, here on the screw, we can check some of the diameters measurements. If we ever want to see how that's tracking, we can just right mouse click and go to measure trend. So right there is the tracking that we've done over several parts. So you can check your process control as you're going through there. We can look in. One of the really nice things that we can handle on this is threads. Okay, so the software has a built-in library of different type of thread types, and by taking a look at that, it'll understand the pitch and the helix, and you can do a lot of the measurements, your pitch diameter, your major minor diameters, as well as some measurement across the roll measurement across the wire.
Now, why would you want to, I mean, once you've got all your pitch and your diameters and all that, why would you want to rotate the screw? I mean, I'm used to seeing screw measurement basically on regular optical comparators, so why rotate the screw? What's that buy you?
A couple things is, one, we can rotate to the start of a thread. So let's assume that you know, maybe we want to fit this against CAD, or we want to make sure that we always rotate so the thread start is at a specific orientation. Then as we come back through, we know that we're always starting at the same location. We don't have to worry about any thread adjustments. That'll help us let us know the effective length of the thread much better.
Okay, and besides threaded parts, what other types of parts do you measure?
Well, any type of turn parts or shaft parts that have cylindrical attributes. Right here we have a different part. Once again, a medical type part. It's an abutment for dental implants. Just tighten this in here. Just go ahead and pull up the routine real quick. It's very simple. Now, we don't have it set up here, but we certainly have the option of putting a barcode reader. So my operator could just walk up, hit the barcode scanner, and bring it up. I just hit start right here, and you're going to see, once again, this is going to do a measurement. Now, you're going to notice something here is we're going to use the rotation to present the part in the two orientations that we need.
Okay.
Okay, so the first part here, we come up, we scan, we get the overall height. We then drop down, and now we're going to scan this around, and you can see it rotating there, so it's measuring. And now it's going to rotate with the abutment facing toward me. Okay, so now when we do this scan, we're getting at the profile, so we can check the angle of that shaft as it comes along from the center line.
So I'm assuming to find the profile, it's looking for. It can detect when it's reached that point where you're seeing the full 90-degree profile to the part, right?
That's correct.
So basically, when you program it to say I'm looking for the profile, then it takes care of aligning to make sure it actually has the profile.
Absolutely. If we look here at the model window here, we just rotate that until it's at the maximum left position, and then that lets us know that we've reached that 90-degree angle position.
Now, is it doing that after it's collecting the data, or is that doing this orientation and then doing the scan?
That's right. It does the orientation first, and then we go through and we do a secondary vertical scan and capture all the data. The nice thing is, unlike an optical comparator where you have to grab each point individually, we can do one scan and then go back in and analyze any of the data that we need to do from there.
Okay. And one thing I forgot to get back on the screw measurement. When you were taking, I think you called it the dynamic measurement.
Right.
So that's actually looking, what that I think you pointed out is that actually lets you see the roundness of a part, right?
Yes.
Okay.
Yeah, that'll allow us to do that.
Throw this one, conicity. I mean, if you were measuring like this has a taper to it, I see on this part. You can also look at that, or can that?
We could go through and plot a number of different diameters.
Okay.
So a known height, check that diameter,
Sure, okay.
Index up, and then just keep moving upward in that manner. Yeah.
All right. Got it.
Another thing it lets us do here, if we look at this measurement right here, what that does, it looks kind of unique there, is that's actually checking the clocking, the width, and the angle of each of the flats. There's a hex down on the bottom of this, so it's letting us know is each hex face opposite to one another, and then what's the angle between the adjoining sets of hex faces.
Okay.
Yeah, so it's very, very good.
Now, what did you already say? What size parts you can fit on this machine?
This particular machine, 16 millimeter diameter by 100 millimeter long. Now, we have a number of offerings that go much larger, including 120 millimeter wide by up to about 1,250 millimeters in length. So we can do some very large parts. Capacity gets up around 200 pounds when you start getting into the bigger machines.
And is this a shop floor tool or a lab tool? I mean, temperature compensation, that sort of thing?
On the X5 that we have here, it's designed to kind of be in a controlled environment.
Okay.
A lot of the shops that are making these parts are very controlled, so we're probably good putting it near the floor there. If it's not, then you need to put it in a lab. A number of the larger machines have built-in environmental compensation. They have some doors that go over the front, light bars to make sure you don't stick your hand in there while it's doing some measurements,
Sure.
and a lot of compensation that can handle being out on the shop floor.
And what kind of price range?
Price range varies from the upper 40s up to about $85,000, $90,000, depending on some of the options. There's a lot of different accessories that you can use for holding the parts and the different size travel machines.
And I've noticed, I mean, obviously to run it was very easy. You just basically hit the start button,
Yep.
select your program, hit your start button, it goes. What about programming the machine?
Programming is not all that difficult. Once we have that vertical scan, we can bring it in here. And if we want to come in, and I'll just do a quick measurement diameter here. Pull up the width right here. And we will go with, get back in here to the measurement. And we'll pull up a new one. There we go. Tell it what we're going to do. Tell it we want to do a quick diameter. And we can just grab this, slide it right up here, shrink the size down,
Okay.
and hit calculate. And there you go. There
So
gives us
basically
the
you
diameter right across there.
You just drew a box. You drew a box around the area of interest, told it what kind of measurement you were going to do. It does the rest, including, I'm assuming, if you need some sort of alignment, that is handled automatically.
Right, yeah,
as well.
there's types of alignment that can be done for any sort of part orientation.
Okay, great.
Yep.
Well, Chuck, I appreciate it. This was the Vici Vision. Did I have that right? From OGP.
Yep.
And if you got any further questions, there is a link on the bottom of our screen that people can get out there, and I believe that links directly to the Vici Vision, right?
I believe so. You can also go to www.ogpnet.com. You can find out more about the Vici, as well as find your local OGP channel partner.
Okay, appreciate it. Thanks, Chuck.
All right, thanks.
Okay, Mike.
All right. Well, thank you, Chuck. Thank you, Dirk, and of course, thanks OGP for providing the Vici Vision to us for today's Tech Corner. Always good to have a guest in the studio to demo the newest product. And again, if you want more information on the Vici Vision, just check out the link right below the player page right there. Well, Dirk, great Tech Corner.
Yeah, it's fun.
really.
Yeah, it's fun. Our new, actually, our
That's right.
brand new set, and it's nice to break it in with a new product from OGP.
Yeah, that's great. New product in North America. So again, thanks for that. If you have a Tech Corner product that you'd like us to demo here on the show, just write us at QDL@qualitydigest.com, and we'll get it on the air for you in an upcoming episode. Well, before we call it a day, we want to talk to you about something we're doing next week on the show. We actually won't be here in Northern California. Actually, we will be in Northern California.
Yeah,
we're going to be just not here in Northern California. We're going to be in Squaw Valley for ETQ's user conference.
That's a tough place to go.
That's a tough place. It's tough work doing this every week. But we're going to be covering their user conference and talking about a few things and a few upcoming things that we're doing with them later on in the month of October. So check that out. It'll be the same time, same channel, 11 a.m. Pacific, 2 p.m. Eastern next week. We'll be live from Squaw Valley Resort.
Squaw Valley Resort. That's right.
Great place. You'll have some great backdrops to see.
1968 Olympics, I think.
Yeah, beautiful. Great. Should be great. So look out for that one. And that's the show. But again, thank you OGP and Chuck for coming out and showing us the Vici Vision. Thank you to Barefoot Wines, of course, for giving us a great article, and David Schwinn for a great article as well.
Yep.
And we will be hopefully back next week if this bottle is still
And by
here.
the way, thanks also. A lot of people participate in our comment section. I mean, really, thanks a lot to Kyle, and also to Mark Graben and Karen and Rip Stouffer and everybody else who jumps in and leaves their comments and keeps the discussion going. I mean, that's what makes quality, is if we can keep hammering on the details and sharing different opinions.
Yes, thank you. That's good. Good call there. And please keep doing that and keep writing us and letting us know what you think. Okay, that's the show. So thanks for joining us. You all have a great weekend, and we'll see you next week.
Cheers.
Bye.